Hello there, and welcome to Deep Earth Stories. Get comfortable, turn the lights down if you can. Because what we are about to explore together has been waiting a very, very long time for someone to listen, but before that, tell me in comments where are you listening from and what time is there right now. Tonight we're going somewhere very few humans have ever been. Not to a mountain, not to a desert, not to the cold reaches of space. Those spaces where many people look when they want to feel small and humbled and quietly amazed. Tonight, we're going down. Down past the sunlight. Down past the fish you know. Down past the places where submarines travel and whales sing their long, slow songs. Down further still, past the cold, dark water that has never once seen the sun. We're going to the deepest place on Earth. The Mariana Trench. Maybe you're already lying down. Maybe the lights in your room are dim or off entirely. Maybe there is a pillow under your head and a blanket pulled close. Good. That is exactly where I want you to be. You do not need to do anything right now except breathe. Just breathe in slowly and let that breath go. We have nowhere to be tonight. No deadline, no alarm, no task left unfinished that needs your attention right now. The world outside is doing what it always does, turning slowly, quietly in the dark. And for the next little while, all you need to do is listen. I am going to take you somewhere ancient and still and full of quiet wonder, a place that existed long before humans walked the earth. A place that will exist long after everything we have ever built has softened back into the ground. The deepest place on our planet. And as we go there together, if your eyes grow heavy, that is okay. If your breathing slows, that is wonderful. If you drift off somewhere in the middle of this story and wake up not knowing where we stopped, that is perfectly fine. The ocean will still be there, and so will I. So close your eyes if you like, let your shoulders drop, let your hands go still, and let's begin. Chapter 1. The Shape of the World Below. Before we go down, I want you to think about something simple. Think about the ocean, not an ocean you have studied or read about in a textbook, just the ocean you imagine when you close your eyes and let the word float through your mind. Maybe you see waves catching the light. Maybe you see a flat blue horizon stretching out forever in every direction. Maybe you smell something like salt and open air. Maybe you hear the sound of water moving, that slow and endless rhythm that has been going on since before anyone was alive to hear it. The ocean is enormous. You probably already know that. If you gathered all the water on Earth into a single sphere, it would be about 860 miles across. That is hard to picture, so instead, just know this. The ocean covers about 71% of our planet's surface. Most of Earth is water. Most of Earth is deep, dark, heavy water. And most of that water, most of the ocean, is not the shallow, sunlit zone near the shore. Most of it is the deep part, the dark part. The part that has never once known light. Scientists divide the ocean into zones like floors in a very tall building. But imagine this building goes down instead of up. And imagine it is made of water and cold and dark. The first zone, the one near the surface, is called the sunlight zone. It goes down about 200 meters. That is roughly 650 feet. In this zone, there is light. There are fish you would recognize. There are corals and dolphins and sea turtles, and the kind of blue that makes you want to swim. This is the ocean most of us picture. Below that is the twilight zone, from about 200 meters down to about 1,000 meters. The sunlight here is so faint it barely counts as light at all. It is more like a memory of light, a dim, cold, blue-grey whisper. Some creatures live here that have developed their own lights, tiny chemical lanterns built into their bodies. They blink slowly in the dark like distant stars. Below the twilight zone is the midnight zone. from 1,000 meters to about 4,000 meters. Here, there is no light at all, none. It is completely, perfectly dark. The pressure at this depth is immense, so heavy that it would crush a human body without any protection almost immediately. The temperature is just a few degrees above freezing. And yet life exists here. Slow, patient, extraordinary life. Below even the midnight zone is the abyssal zone, from 4,000 meters to about 6,000 meters. The word abyssal comes from the Greek word for bottomless. The people who named this zone must have felt exactly the way it sounds, like looking into something that simply never ends. And then, at the very bottom of the abyssal zone, there are trenches. The places where the ocean floor drops suddenly, steeply, dramatically downward into narrow canyons far deeper than anything else on the planet. And the deepest of those trenches, the deepest known point on the entire surface of the Earth, is the Mariana Trench. Located in the western Pacific Ocean, not far from the island chain called the Marianas, this trench is roughly 2,550 kilometers long. That's about 1,580 miles. If you laid it across a map of the United States, it would stretch from New York almost to Denver. It curves in a gentle arc, like a long, slow crescent carved into the floor of the sea. And at its deepest point, a place called Challenger Deep, it reaches a depth of about 10,935 meters. That is nearly 11 kilometers down, or in feet, almost 36,000 feet. To give you a sense of what that means, if you took Mount Everest, the tallest mountain on land, and placed it at the bottom of Challenger Deep, its peak would still be more than a mile underwater. Everest would be completely swallowed. The Mariana Trench is not just the deepest place on Earth. It is so deep that it feels like a different world entirely. A world with different rules. A world where the pressure is about 1,000 times greater than the pressure at sea level. Where the temperature hovers around just 1 to 4 degrees Celsius. Where there is no light, almost no food, and conditions that seem, by every reasonable measure, impossible for life. And yet, life is there. But we're getting ahead of ourselves. Let's breathe for a moment. Let's slow down. For a moment, just breathe. Feel the weight of your blanket. Feel the softness of the surface beneath you. You are warm. You're safe. The world outside your window is quiet, and below all of it, far below everything, the Mariana Trench sits in its darkness, patient as it has always been. We will get there slowly, gently. There is no rush. Chapter 2: How the Trench was born. Every deep place in the world has a story about how it was made, and the Mariana Trench has one of the oldest, slowest, most powerful stories of all. To understand it, I need to tell you a little bit about the ground beneath your feet. Even right now, lying still and quiet, you're sitting on a giant plate of rock, not a dinner plate, a tectonic plate, a vast, slow-moving slab of the Earth's crust that covers a portion of our planet's surface and floats, very slowly, over the hot, semi-liquid rock beneath. The Earth's surface is divided into several of these plates, about 7 major ones and many smaller ones. They do not sit still. They move, very slowly, about the pace that your fingernails grow, roughly a few centimeters a year. But over millions of years, even that tiny movement adds up to enormous change. These plates have been moving since the Earth was young. They have built mountains by crashing into each other and lifting rock toward the sky. They have opened oceans by pulling apart and letting new rock rise up from below to fill the gap. They have caused earthquakes, volcanoes, and tsunamis. All of the great geological drama of our planet, all the mountains and valleys and ocean basins and canyons, comes in large part from these plates moving and colliding and shifting over deep time. The Mariana Trench was made by a collision. Specifically, it was made by a collision between two plates. The Pacific Plate, which is one of the largest tectonic plates on Earth, and the Mariana Plate, which is much smaller. When two tectonic plates collide, something has to give. One plate has to go somewhere. And what happens in many cases, especially when one plate is denser than the other, is something called subduction. Subduction. It is a quiet word for something enormous. It means one plate slides beneath the other and begins to sink slowly down into the hot interior of the Earth. In the case of the Mariana Trench, the Pacific Plate is the one that subducts. It is old rock, some of the oldest ocean crust on Earth. And old ocean crust is dense and cold and heavy. When it meets the Mariana Plate, it slides underneath, bending downward at a steep angle, disappearing slowly into the mantle below. And where the Pacific Plate bends down, where it makes that long, slow curve toward the deep Earth, it leaves behind a scar, a long, narrow, enormously deep scar in the ocean floor. That scar is the Mariana Trench. It has been forming for about 180 million years. That is not a number the human mind was built to understand intuitively, so let me give you something smaller to hold. 180 million years ago, dinosaurs roamed the Earth. The supercontinent Pangaea was still in the slow process of breaking apart. There were no flowers, no bees, no grass. The continents we know today were just beginning to drift into rough approximations of their future positions. And even then, even 180 million years ago, the Mariana Trench was already forming, already deepening, already creating that long, dark channel in the floor of the Pacific. It has been growing, very slowly, ever since. Right now, as you lie there with your eyes closed and you're breathing slow, the Pacific Plate is still moving, still bending. He is still sliding under the Mariana Plate at a pace of a few centimeters a year. The trench is not finished. It is not a static thing, a photograph, a fossil. It is a living geological feature still in the process of becoming. The Earth is still making it. There is something about that I find deeply calming. The idea that the world's deepest place is not ancient and frozen and done, that it is still being shaped, that time is still working on it, slowly and without drama, the way time works on everything, including us. We are also still becoming, still being shaped, and like the trench, we have more time to go than we sometimes realize. But let's drift a little further into the story and talk about the people who first found this place. The people who first looked at the surface of the Pacific Ocean and asked, how deep does it go? Chapter 3. The First Discovery. It is the year 1875. The world is a very different place. There are no airplanes, no satellites, no smartphones, no internet. Most of the deep ocean is entirely unknown to science. People know the ocean is deep in places, but they do not know how deep. They have no real way of measuring it from above the surface. Into this world of unknowing comes a ship. Her name is HMS Challenger. She's a British naval vessel, converted for scientific purposes. She has been sailing the world's oceans since December of 1872, on a voyage that will last almost 4 years and cover nearly 69,000 nautical miles. She carries scientists, naval officers and crew. She carries nets and ropes and thermometers and chemical equipment. And she carries a very special tool, a sounding line. A sounding line is a simple thing. It is a long rope with a weight attached to the end. You drop it over the side of the ship, you let it fall, you pay out rope, and you pay out rope, and you wait until the weight touches the bottom. Then you measure how much rope you let out. It is slow, it is imprecise. It takes hours to lower the line to the bottom, and hours more to bring it back up. But it is what they have, and it works. On the 23rd of March, 1875, HMS Challenger is sailing in the Western Pacific, in the waters east of the Mariana Islands. The scientists lower their sounding line. They pay out rope, and they pay out rope. They wait. More rope. Still more. The weight finally touches bottom. They measure 8,184 meters. That is about 26,850 feet. The crew looks at each other. They check the measurements. They lower the line again to be sure. It is real. They have found the deepest place ever recorded by human instruments. They have found the edge of the Mariana Trench, or at least a part of it, without knowing the full shape of what they have found. They do not know it stretches for over 1,000 miles. They do not know it goes even deeper further south. They do not know that the very bottom, Challenger Deep, will one day be measured at nearly 11 kilometers. But they know something enormous. They know the ocean is deeper than anything anyone ever imagined. They write it in their log. They mark their position. And HMS Challenger sails on, carrying this astonishing piece of knowledge with it across the rest of the Pacific, back across the ocean, and eventually home to England, where the voyage's findings will take decades to fully process and publish. The trench was named after the Mariana Islands nearby, and the deepest point within the trench, Challenger Deep, was named after that ship. After those quiet sailors who dropped a rope into the dark water and found, to their astonishment, that it kept going and going and going. There is something I love about that discovery. It was made with such a simple tool. A rope, a weight, patience, the willingness to sit with the not knowing while the rope paid out, while the weight fell through thousands of meters of cold dark water. Maybe that is a kind of lesson for tonight. The deep things take time to reach. You do not rush to the bottom of the ocean. You lower your line slowly and you wait, and you trust that eventually you will know what you need to know. For a moment, just breathe. Let the weight of your body sink gently into the mattress, like a sounding weight, slowly descending. You are not falling, you're settling, finding your depth. Let's continue the story. Chapter 4. The Long Silence. After HMS Challenger's discovery in 1875, something interesting happened. Not much. The world noted the discovery. Scientists published the findings. The Mariana Trench was acknowledged as extraordinarily deep. And then, for many decades, the deep ocean remained almost entirely unexplored. This is not because people were not curious. It is because they had almost no way to go there. Think about what it means to descend to the bottom of the Mariana Trench. The pressure at Challenger Deep is about 1,086 bars. 1 bar is roughly the pressure of the atmosphere at sea level. Yeah, the weight of all the air above you pressing down on every square centimetre of your body right now. At Challenger Deep, that pressure is multiplied more than 1,000 times. To put it another way, the pressure at the bottom of the Mariana Trench is roughly equivalent to having about 50 jumbo jets stacked on top of you. Every square inch of your body would experience thousands of pounds of force pressing in from all sides. The human body cannot survive that without extremely specialised protection. And in the early 20th century, no such protection existed. Even the most advanced submarines of that era could not go anywhere near those depths. So the trench sat, dark and silent and patient. For 75 years after HMS Challenger's discovery, no human instrument had gone anywhere close to the bottom of the Mariana Trench. The ocean floor there remained completely unknown. Scientists could measure sound waves bouncing off the bottom. They could infer its rough depth and shape. But actually going there, actually seeing it, that was something from the future, and yet people dreamed about it. In 1934, a biologist named William Beebe descended to a depth of 923 meters in a hollow steel sphere called a bathysphere, lowered by a cable from a ship. It was a remarkable achievement for its time, though nothing close to the depths of the Mariana Trench. Bibi described what he saw through the small, thick porthole, the utter darkness, punctuated by tiny flashes of bioluminescent light. He said it felt like floating in space. Engineers and scientists throughout the 1940s and 1950s worked on the problem of deep ocean pressure. How do you build a vessel that can withstand 1,000 times the pressure of the atmosphere? How do you keep the occupants alive and the vessel intact? The answer came from a Swiss engineer named Auguste Piccard. Piccard was a remarkable man. He had already set world records for high-altitude balloon flight, ascending into the stratosphere in a pressurized gondola of his own design. He had thought long and hard about the engineering of extreme environments, the thin, cold emptiness of the upper atmosphere, and the crushing, dark heaviness of the deep ocean. In his mind, they were related problems. Both required a small, sealed, pressurized space where humans could survive conditions that would otherwise kill them. He designed a vessel called a bathyscaphe. The word comes from Greek, bathi meaning deep, and scaphe meaning boat, a deep boat. The bathyscaphe worked on a principle of buoyancy. The crucisphere, a thick steel ball designed to resist enormous pressure, was attached to a large float filled not with air but with gasoline. Gasoline is lighter than water, so it provided the buoyancy needed to keep the sphere from simply sinking to the bottom. To descend, the crew released some of the gasoline and took on ballast, heavy iron pellets that made the vessel heavy enough to sink. To ascend, they released the iron pellets and let the gasoline float them back up. It was elegant, simple in principle, enormously complex in execution. Piccard's bathyscaphe, called the Trieste, was eventually purchased by the United States Navy, and the Navy had a mission in mind: the deepest place on Earth. As we drift toward the end of this first chapter in our story, let us pause here for a moment. Let the image settle. A small steel ball, about 2 meters across on the inside, 2 men inside it, and the deepest, darkest water in the world below them. We will go down with them in our next chapter, but for now, if your eyes are heavy, let them close. If your breathing has slowed, that is exactly right. Notice the quiet around you, the soft darkness of your room, the warmth of where you lie. You are safe. You're still. The world is turning slowly, and so are we. The Mariana Trench is patient. It has been waiting for millions of years. It can wait a little longer while you rest. Let's drift a little further into the story, where 2 brave men will do something no human being had ever done before, or has done many times since. They will go to the very bottom of the world. Chapter 5. Going Down. It is the 23rd of January 1960. The sky above the Western Pacific is pale and grey. The water is calm, the way deep ocean water often is on the surface, smooth and indifferent, giving no hint at all of what lies below. A support ship sits quietly in the water, rocking in the gentle swell, and below it, attached by ropes and hoses, floats the Trieste. She does not look like much from the outside. A large white float filled with gasoline, roughly the shape and size of a small submarine. And underneath the float, bolted firmly to its belly, is the crucisphere, a hollow steel ball about 2 meters in diameter, walls nearly 13 centimeters thick, nearly 5 inches of specially forged steel designed to resist pressures that would crumple ordinary metal like paper. Inside that sphere, 2 men are preparing. Their names are Jacques Piccard and Don Walsh. Jacques is the son of Auguste Piccard, the man who designed the Trieste. He grew up hearing his father talk about the deep ocean, the way other fathers talked about their gardens or their workshops. The deep ocean was the family project, the great impossible dream made slowly real over years of engineering and testing and failure and refinement. Jacques knew this vessel the way you know a thing you've grown up with. He trusted it completely, or as completely as any person can trust something about to do something no one has ever done before. Don Walsh was a United States Navy lieutenant, 28 years old, young, calm, methodical, a man who had chosen the ocean as his life and was now, on this particular January morning, about to descend further into it than any human being ever had. They climb inside. The hatch is sealed behind them. The sphere is small. 2 men, the instruments and controls, and very little else. There is no room to stretch, no room to pace, no room for anxiety to move around in. Whatever you feel inside the Trieste, you feel it in close quarters, with the walls of thick steel just an arm's length away in every direction. Below them, Challenger, deep. Nearly 11 kilometres of dark water. The ropes are released. The Trieste begins to sink. At first the descent is gentle. The water near the surface is faintly lit, the pale blue-green that filters down from the sky above. Jacques and Don watch through the small porthole as the light slowly dims. The surface recedes. The ship above them grows smaller and then disappears. The world of air and sky and sunlight seals itself away above them like a door closing softly. They're going down. For a moment, just breathe. Imagine what it feels like to be inside that small steel sphere sinking through the water. You cannot see the bottom. You cannot see the surface. You're suspended in the middle of something vast and dark and completely indifferent to your presence. The only sounds are the quiet hum of instruments, your own breathing, the soft creak of metal settling under increasing pressure. The descent takes 4 hours and 48 minutes, nearly 5 hours of sinking, nearly 5 hours of watching the pressure gauges climb, the temperature gauges drop, the depth meters tick steadily downward. 5 hours of darkness growing deeper outside the porthole. Then 5 hours of being very small inside a very small steel ball inside a very large and very dark ocean. At around 9,000 meters, something alarming happens. There is a sharp crack. Loud, sudden. The kind of sound that in an enclosed space feels enormous, like something breaking. Jacques and Don freeze. They check instruments. They look at each other. They wait. It turns out to be one of the outer plexiglass window panes on the entry tube cracking under the pressure. Not the main viewport, not the hull. The vessel is still intact. They are still safe. They make the decision to continue. They keep going down. At 10,916 meters, the Trieste touches the bottom of Challenger Deep. A small cloud of pale sediment rises up around the vessel as it settles gently on the floor. Diatomaceous ooze, the scientists will later call it. Ancient sediment made of the remains of billions of tiny organisms that have rained down from the sunlit surface over millions of years, drifting slowly downward through the dark water and settling here in this quiet, impossible place. Don Walsh later said that when they touched down, it was like landing on fresh snow, soft, gentle, a slow, quiet arrival. They are at the bottom of the world, and outside the porthole in the beam of the Trieste's lights, Jacques Picard sees something that astonishes him. A fish, a flatfish, he believes, lying on the sediment floor, alive. There is life here. At nearly 11 kilometers below the surface, in darkness and cold and pressure that should make life impossible, a creature is simply living its life, resting on the ooze, being a fish in the deepest place on Earth, as Jacques later writes about this moment with quiet joy. To find life there, in that place, felt like a kind of answer to a question no one had quite known how to ask. If life exists here, what does that mean about life everywhere else? About how persistent it is, how creative, how determined to fill every space the universe offers. They stay on the bottom for 20 minutes. Then they release the iron ballast and begin the long, slow journey back up. 3 hours and 15 minutes later, they break the surface. The sky still pale and grey. The support ship is there. The world of air and sunlight is exactly as they left it. But Jacques Picard and Don Walsh are different. They have been somewhere no human being had ever been. They have seen the bottom of the world, and they have come back. Chapter 6. The Long Wait. After. Something surprising happened after the Trieste's historic dive in 1960. The world paid attention for a moment. The achievement was noted, celebrated, written about. 2 men had descended to the bottom of the Mariana Trench. That was extraordinary. That was historic. And then, for more than 50 years, no one went back. 50 years. Think about that for a moment. Humans walked on the moon in 1969, 9 years after the Trieste's dive. We built space stations. We sent probes to the outer edges of the solar system. We mapped the surface of Mars with robotic rovers. We looked at galaxies billions of light years away with orbiting telescopes. And yet the deepest place on our own planet, the place right here on Earth, in our own ocean, went unvisited by humans for half a century. Part of this is about cost and difficulty. Reaching the bottom of the Mariana Trench is extraordinarily expensive and technically demanding. Space exploration has attracted enormous funding and public attention. Deep ocean exploration, by comparison, has always been underfunded, less glamorous in the public imagination. Part of it is also about what we expect to find. The moon had the promise of discovery, the romance of stepping somewhere no human foot had ever touched. The deep ocean, for a long time, was imagined as mostly empty, dark and cold and barren. We now know that is completely wrong, but that knowledge came slowly, quietly, the way most important truths do. During those 50 years, unmanned vehicles, remotely operated probes and landers, did visit the Mariana Trench. They brought back photographs and sediment samples and measurements. They revealed a world far more complex and inhabited than anyone expected. But the images were distant and grainy. The probes were limited in what they could do, where they could go, what they could capture. The deep ocean was still in many ways a mystery. It remained that way until 2012. That year, a filmmaker named James Cameron, known to most people for directing the films Titanic and Avatar, climbed into a specially designed submersible called the Deep Sea Challenger and descended alone to the bottom of Challenger Deep. Alone. One person in a small vertical torpedo-shaped vessel, painted green, making the deepest solo dive in history. Cameron had spent years working with engineers to design the Deep Sea Challenger. It was a different kind of vessel from the Trieste. Narrow and elongated, built to sink quickly. The descent took only 2 hours and 36 minutes, compared to the Trieste's nearly 5. It carried far more sophisticated cameras and sampling equipment. It was built not just to go deep, but to look carefully at what was there. Cameron spent 3 hours on the bottom. He collected sediment samples. He filmed with 3D cameras. He manoeuvred through the ooze and took the most detailed footage of Challenger Deep ever captured. He later described the bottom as a lunar desolate place, flat, pale, dim under the submersible's lights. He saw no fish, unlike Picard's reported sighting 50 years earlier. He saw small crustaceans called amphipods skittering across the sediment. He found traces of life, but a life quieter and stranger than anything we encounter on the surface. When he surfaced and stepped out onto the deck of the support ship, Cameron said simply, "I felt like I was in the ultimate wilderness. The ultimate wilderness, below every ocean wave, below every ship's hull, below the deepest diving whale and the coldest darkness we normally imagine when we think of the sea. Below all of that, there is still more, still further down, still deeper. And at the very bottom, there is a wilderness no human will ever fully explore. For a moment, just breathe. If your eyes are heavy, that is okay. You do not need to follow every word. Let the story wash over you like water, like the slow, cold current moving through the deep places of the ocean, steady and unhurried. The Mariana Trench is still there. It is not going anywhere. It will be waiting when you come back. Chapter 7. The Pressure World. Let us talk for a little while about pressure. Not pressure the way we usually use that word. Not the pressure of a deadline or a difficult conversation or a long list of things to do. The other kind, the physical kind, the weight of water pushing in from all sides. Because pressure is the defining fact of life in the Mariana Trench. It shapes everything. It determines what can live there and what cannot. It explains why no ordinary creature from the surface could survive there, and why the creatures that do live there are unlike anything we encounter in our daily world. At sea level, the atmosphere presses down on your body at about 14.7 pounds per square inch. Your body has lived with this pressure your entire life. Your cells are built to handle it. Your lungs are built to handle it. You never feel it because your internal pressure matches the external pressure, and the two balance each other perfectly. In the sunlit zone of the ocean, the pressure increases as you descend. For every 10 meters you go down, you add another full atmosphere of pressure. At 10 meters, you have twice the pressure of sea level. At 100 meters, 11 times. Scuba divers feel this. They feel their ears needing to pop, the air in their lungs compressing, their body adjusting to the increasing weight of water above. At the bottom of Challenger Deep, the pressure is about 1,086 atmospheres. That is 1,086 times the pressure at sea level. In pounds per square inch, that is roughly 15,960 pounds per square inch. Your body, at that depth, would not be crushed in the dramatic way that movies sometimes portray. It is more complex and more complete than that. Every airspace in your body would collapse instantly. Lungs, sinuses, ears, all gone. The tissues themselves would compress and deform under forces they were never built to withstand. And yet, life is there. The question of how life survives at those pressures is one of the most fascinating in all of biology. And the short answer, the beautiful answer, is this: life adapts. The creatures of the deep ocean have bodies that are built for pressure rather than against it. They do not have air spaces that can collapse, because they have no air spaces at all. Their cells, their proteins, their very molecular machinery has been shaped over millions of years of evolution to function under enormous compression. One of the key molecules in this adaptation is called trimethylamine oxide, or TMAOM. This is a small molecule that cells use to stabilize proteins under pressure. Without it, the proteins in a cell, the molecular machines that do the work of life, would become stiff and non-functional under high pressure, like gears that seize up in extreme cold. TMAO keeps them flexible, keeps them working, keeps life possible. Interestingly, the deeper a fish lives in the ocean, the more TMAO it tends to have in its cells. Scientists have used this as a kind of tool. By measuring the TMAO concentration in a fish, they can estimate roughly how deep it lives. It is a chemical signature written into the animal's body by the pressure of its world. Imagine that. The depth of the world you live in is written into your very cells. There is something quietly poetic about that. We're all shaped by the pressure of our environments, written into by the conditions we live in. The fish at the bottom of the Mariana Trench carries the depth of the ocean in its molecules. We carry our own histories in ours. Let's drift a little further. Chapter 8. The Strange Lives Below. I want to tell you about some of the creatures that live in and around the Mariana Trench. not in a clinical, list-like way, in a soft, wondering way. Because these animals are genuinely extraordinary, and thinking about them slowly and gently is one of the most calming things I know. Let us start with the amphipods. Amphipods are small crustaceans, related distantly to shrimp. Most of the ones you might encounter near the surface are tiny, a few millimeters long, almost invisible to the naked eye. But in the deep ocean, something strange happens. Animals often grow larger than their shallow water relatives. Scientists call this deep sea gigantism, and it is one of the many puzzles of the deep. In the Mariana Trench, amphipods have been found that are several inches long. One species, Alochella gigantea, can reach almost 34 centimeters. That is over a foot long for an animal that in the sunlit world would be barely visible. They gather in enormous numbers around food falls, the carcasses of whales, fish, and other creatures that drift down from the surface. When a whale dies and sinks slowly to the deep ocean floor, it carries with it an enormous gift. Years, sometimes decades worth of food for the creatures of the abyss. A single whale carcass can support a complex ecosystem on the deep ocean floor for decades. The amphipods arrive first, sometimes in the thousands. They swarm the carcass, stripping flesh from bone with quiet efficiency. They are not frightening creatures. Seen in slow-motion footage, they look almost delicate. Translucent bodies, long antennae, moving with a slow, drifting grace in the dark water. Then there are the sea cucumbers. Sea cucumbers are animals related to sea urchins and starfish. In shallow water, they are modest creatures, tube-shaped, soft-bodied, living quietly on the ocean floor, eating sediment and passing it through their bodies, extracting what nutrition they can. In the deep ocean, some species of sea cucumbers have evolved to be remarkably mobile. They undulate through the water, moving in slow motion, when their bodies rippling gently. In some of the deepest parts of the Mariana Trench, sea cucumbers make up a large proportion of the total animal biomass. In some surveys, they have accounted for more than 90% of the life observed. In those dark valleys, if you were able to look, you would see them everywhere. Pale, slow-moving shapes drifting through the ooze and the cold water, going about their quiet business. There is something very soothing about that image. A world of pale, gentle creatures moving slowly through the dark. No hurry, no alarm, just the slow work of living. Then there are the snailfish. The snailfish are, as of the most recent scientific records, the deepest living fish ever found. In 2023, cameras captured a juvenile snailfish at a depth of approximately 8,336 meters in the Izu-Ogasawara Trench, near the Mariana. And in the Mariana Trench itself, snailfish have been found at depths exceeding 8,000 meters. They look almost nothing like what the word fish brings to mind. They're small and pale, almost translucent, with soft bodies and delicate fins. They look fragile. They look like something that should not exist, like something from a dream of the ocean rather than the ocean itself, and yet they are perfectly suited to their world. Their cells are full of TMAO. Their bodies are built to flex and flow under pressure rather than resist it. They eat the small crustaceans and other creatures that gather around food falls, moving with surprising speed and agility in pursuit of prey. Watching footage of them is strange and beautiful. In the black water, illuminated by the lights of a research lander, they swim in slow, weaving arcs, their pale bodies ghostly, their movements dreamlike. They are fish from another world. A world that has been here all along beneath the one we live in. For a moment, just breathe. Notice your body. Notice the weight of it, resting. Notice the warmth around you. You're at the surface of things, at the top of the air, at the brightest, warmest, most familiar part of the world, and somewhere below you, below oceans and sea floors and sediment and slow-moving tectonic plates. Below all of the known world, pale fish drift in the dark. It is okay if your eyes are very heavy now. It is okay if this story has become more like a dream than a documentary. That is what it is meant to become. Let the deep ocean hold you softly. Let's drift just a little further. Chapter 9. What the sediment remembers. At the bottom of the Mariana Trench, the floor is covered in a layer of very fine sediment. Scientists call it hadal sediment, named for Hades, the underworld of ancient Greek myth. The hadal zone is any part of the ocean deeper than 6,000 meters from the same root. These names were given by people who perhaps felt something a little mythological about these places, dark and deep and removed from the world of the living. The sediment at the bottom of Challenger Deep is made of many things. There is diatomaceous ooze, made from the silicon shells of tiny algae called diatoms that live in the sunlit surface waters. When they die, their shells drift downward. For millions of years they have been doing this, living briefly in the sunlit zone, dying and sinking slowly down through thousands of meters of water, coming to rest at last on the deep floor. There is foraminifera ooze, made from the shells of tiny single-celled organisms called foraminifera, which are among the most successful and long-lived creatures on Earth. They have been here for hundreds of millions of years. Their shells accumulate in layers on the ocean floor, one generation settling on top of the last, building up over geological time into thick records of the past. Those layers are a kind of library. Scientists who study deep-sea sediment cores, long cylinders drilled out of the ocean floor, can read them like a book. Each layer tells a story. The chemistry of the shells changes depending on the temperature and chemistry of the water when the organisms were alive. By analysing those changes, scientists can reconstruct the history of the ocean's climate going back millions of years. They can see ice ages and warm periods. They can see mass extinctions. They can see the slow, enormous cycles of the Earth's climate, written in sediment at the bottom of the sea. The floor of the Mariana Trench is a record of almost everything, and it is being added to right now. Even as you lie there, even as your breathing slows and your thoughts become soft and wandering, tiny diatoms are living and dying at the surface of the Pacific Ocean. Their shells are beginning the long, slow fall. In thousands of years, they will reach the bottom of Challenger Deep and settle into the sediment, adding one more thin layer to the record. Time works this way, very slowly, layer by layer. One of the most striking recent discoveries about the hadal sediment of the Mariana Trench is something that saddens me a little, though I will tell you about it gently, because even difficult truths can be held softly at night. In 2017, researchers found high concentrations of persistent organic pollutants in the bodies of amphipods collected from the deepest parts of the Mariana Trench. These pollutants, chemicals like PCBs and PBDEs, used in industrial processes and electronics, were present in the deep-sea creatures at concentrations far higher than in many contaminated coastal environments. The chemicals had not gotten there directly. They had travelled through the food web, absorbed into organic matter at the surface, and carried down by falling particles in the bodies of dead organisms. Over decades, they had accumulated in the deep ocean, even here, even at the bottom of the world, even in the place most removed from human activity on the entire surface of the Earth. Our fingerprints are there. I tell you this not to leave you with a heavy feeling at the edge of sleep, but because it seems important to acknowledge. The ocean is not separate from us. It is connected to everything we do. Every piece of plastic that enters the water, every chemical, every molecule of pollution, it travels, it sinks, it ends up in some form in the deepest places. But there is a gentler side to this truth too. If our actions can reach the bottom of the ocean, if our connection to that distant, dark, quiet world is so real and so deep, then perhaps the reverse is also true. Perhaps what we do to protect the ocean, to reduce our pollution, and just to take care of the surface world can also travel down. Perhaps care, like chemicals, moves through the system. The ocean is not apart from us. We are part of it, and that feels like something worth sitting with, quietly, in the dark. Let your breathing slow. Let the story settle around you like sediment settling slowly in still water. The Mariana Trench holds everything. The history of the planet, the chemistry of millions of years, the pale, drifting lives of creatures no human has ever touched. And now, quietly, a little of us too. We will continue this story soon. There is still more to explore. The sounds of the deep, the hydrothermal vents, the strange chemistry of water under impossible pressure, and the quiet philosophical questions that this ancient place asks of all of us. But if sleep is coming for you now, welcome it. Let it come. The trench is not going anywhere. The pale fish are still drifting in their dark and quiet world, and you are safe and warm and resting at the very surface of things, where the light still reaches. Chapter 10. The Sound of Deep Water. There is something I have not yet told you about the deep ocean. It is not silent. When most people imagine the bottom of the Mariana Trench, they imagine silence. Complete, total, absolute silence. The kind of silence that has no edges, no texture, no movement at all. And in one sense, they are right. There is no wind down there, no rustling of leaves, no traffic, no voices, no bird song. The world of air and its sounds does not reach those depths, but water is a remarkable conductor of sound. Far better than air, actually. These sound travels through water at about 1,480 meters per second compared to about 343 meters per second through air. Sound in water moves more than 4 times faster, and it travels much farther. A sound made in one part of the ocean can, under the right conditions, travel for thousands of miles before fading into nothing, and the deep ocean is full of sound. In 2014, scientists from the National Oceanic and Atmospheric Administration lowered a very sensitive hydrophone, an underwater microphone, into the Mariana Trench. They recorded for 3 weeks. What they captured was not silence. It was a rich, complex, layered soundscape, unlike anything recorded before. They heard the low, groaning rumble of earthquakes in the ocean floor. The Mariana Trench sits in one of the most seismically active regions on Earth, and the sound of the Earth moving, slow, deep, resonant, was a constant presence in the recordings. They heard the calls of baleen whales, enormous animals singing from miles away, their voices travelling down through the water column and reaching even the deepest microphone. There is something extraordinary about that, a whale singing at the surface, its voice travelling down through kilometres of dark water, arriving at the bottom of the world as a low, ghost-like moan. They heard the sound of ships, the distant mechanical throb of vessel engines crossing the Pacific far above. Even there, at the very bottom of the ocean, the sounds of human civilization arrived faintly, persistently. They heard the crackling of shrimp. Yes, shrimp. The snapping of their claws creates a sound that, in shallow water, sounds like the crackling of a fire, and even at depth something of that sound found its way to the microphone, and they heard things they could not immediately identify. Low, tonal sounds that seemed almost musical. Signals that did not match any known biological or geological source. The ocean, even well studied, even mapped and measured, still holds sounds that science has not yet fully explained. The deep ocean speaks. We just need the right instruments to hear it. There is a comfort in that, I think. Even in the darkest, most remote places, there is sound. There is connection. Nothing is truly isolated. The whale song reaches the bottom. The earthquake reaches the microphone. The distant engine arrives as a murmur. Even at the bottom of the world, things are in communication. We are all connected to more than we realize. For a moment, just breathe. Listen to the quiet of your own room. Maybe there is the soft sound of breathing, yours or someone nearby. Maybe there is the distant hum of a city, or the sound of wind outside a window, or the particular deep quiet of a house at night. These sounds are your soundscape. They are the signature of your world, the way the rumble of earthquakes is the signature of the deep ocean floor. Let them be soft background music as we continue. Chapter 11. Hot water in cold darkness. I want to tell you about one of the most astonishing discoveries in the history of ocean science. A discovery that changed everything scientists thought they knew about where life can exist and how it sustains itself. It happened in 1977, not in the Mariana Trench itself, but in the deep ocean not far away, along the Galapagos Rift in the Pacific. Scientists piloting a small deep-sea submersible called Alvin were exploring the ocean floor at a depth of about 2,400 meters when they found something that should not have been there. Warm water. In the deep ocean, where temperatures hover near freezing, they found a place where water was seeping up from cracks in the seafloor, and it was warm. Not just a little warm, startlingly warm. And around those warm vents, clustered in dense, extraordinary communities, was life. An abundance of life unlike anything ever seen at those depths. Tube worms 3 meters long, clams the size of dinner plates, mats of white bacteria coating the rocks, ghostly white crabs and pale fish and countless other creatures, all living in the dark, all thriving without a single ray of sunlight. These were hydrothermal vents, cracks in the seafloor where seawater seeps down into the hot rock of the Earth's crust, is superheated by the geothermal energy below, and then shoots back up into the ocean, carrying with it a rich cocktail of minerals and chemicals dissolved from the rock. The water emerging from some vents is extraordinarily hot. Some vents, called black smokers, release water that can be over 400 degrees Celsius. It does not boil because the pressure at those depths is so enormous that it prevents the water from changing phase. The creatures around these vents do not get their energy from sunlight. There is no sunlight. They get their energy from chemosynthesis, a process where bacteria convert the chemicals in the vent water, particularly hydrogen sulfide, into energy. The bacteria form the base of the food chain. Everything else feeds on them, directly or indirectly. It is an ecosystem built entirely on chemistry, on the heat of the Earth itself. Before this discovery, scientists believed that all life on Earth ultimately depended on the sun. Plants capture sunlight. Animals eat plants. Every food chain, however long or complex, traced back eventually to sunlight and photosynthesis. That was the rule. The hydrothermal vent communities broke the rule. They exist in permanent darkness. They have never needed the sun. They draw their energy from the Earth's internal heat, from the chemistry of rock and water and heat. They are completely independent of the solar-powered world above. Since that 1977 discovery, hydrothermal vents have been found all over the deep ocean, and evidence of similar vent systems has been found, or strongly suspected, goes on other worlds in our solar system. The moons Europa and Enceladus, icy moons orbiting Jupiter and Saturn respectively, are believed to have liquid water oceans beneath their frozen surfaces, kept warm by geothermal heat. And if those oceans have hydrothermal vents, then by the logic of what we found on Earth, they could have life. Life that has never once needed the sun. The discovery of hydrothermal vents did not just change our understanding of the deep ocean. It changed our understanding of what life is and where it can be. It opened up a universe of possibilities that we're still only beginning to explore. And it all started with warm water in a cold, dark place, far below the surface of the sea. Isn't that a beautiful thought to carry into sleep? That warmth exists even in the deepest cold. That life finds a way even in the darkest places. That the rules we think govern everything are always somewhere, being gently broken by something extraordinary and patient and alive. Chapter 12. Time and the Trench. I want to drift with you now into something a little softer, a little more reflective. We have talked about pressure and creatures and sound and the heat of the earth. Now I want to talk about time. The Mariana Trench is, in geological terms, young. 180 million years sounds ancient, and by human standards it is incomprehensibly old. But the Earth itself is about 4.5 billion years old. The Mariana Trench has existed for only about 4% of the Earth's total life. Before the Mariana Trench existed, there was a different ocean. Before that ocean, different continents. Before those continents, a world so unlike our own that it would be almost unrecognizable. No grass, no flowers, different animals, different air, a sky with a slightly different composition than the one we breathe under today. The Earth has been many different Earths, and all of those previous Earths had their own deep places, their own trenches and basins and dark ocean floors. Those old trenches are gone now, subducted back into the mantle, recycled into rock, their secrets dissolved back into the earth. The organisms that lived in them, the sediment that collected on their floors, the sounds that travelled through their water, all of it erased by the slow recycling of the planet's crust. The Mariana Trench will eventually be subducted too, not for tens of millions of years, but eventually. The Pacific Plate will continue to slide beneath the Mariana Plate. The crust will continue to descend into the mantle, and one day, in a future so distant that human language has trouble even pointing toward it, the Mariana Trench will close. The deepest place on Earth will be somewhere else entirely. Or perhaps Earth will be unrecognizable by then. The sun will eventually brighten and expand. The oceans will eventually be lost. The continents will have moved into configurations we cannot predict. The world will be different in ways we cannot imagine. And through all of that, time will continue, patient and indifferent and steady, the way it has always been. I find this thought genuinely calming, not frightening, not heavy, but light and freeing. We're here for a moment, a brief, bright, warm moment in the long, like quiet story of this planet, and this moment matters. It is real and vivid and full of sensation. You can feel the warmth of your blanket right now. That warmth is real. This moment is real. But it is also temporary. And temporary things are not less valuable for being temporary. The flower is not less beautiful because it fades. The sunset is not less beautiful because it ends. We are temporary and we are beautiful. And the world we live in is doing exactly what it has always done. Changing slowly, layer by layer, the way sediment falls on the floor of the Mariana Trench. For a moment, just breathe. Feel yourself resting in the temporary warmth of this particular night, in this particular room, in this brief and quiet moment of your own deep time. The world turns slowly, and so do we. Chapter 13. The hadal zone and its secrets. The deepest parts of the ocean, everything below 6,000 meters, have their own name, the hadal zone, named for Hades, the underworld, the place below the place. There are about 37 known hadal trenches in the world's oceans. Most of them are in the Pacific. They are not all as deep as the Mariana Trench, but they are all extraordinary. each one a long, narrow slash in the ocean floor, each one home to its own community of organisms shaped by that specific depth and chemistry and geography. Scientists who study these places are called hadal biologists, or sometimes just hadal scientists. It is a small and dedicated group. The tools they need are expensive, difficult to build, and often lost. Our landers, unmanned vehicles lowered to the ocean floor on long ropes, are the primary research tool. They carry cameras, bait traps, and sampling equipment. They are lowered carefully, reach the bottom after many hours, collect what they can, and then are recalled to the surface. Sometimes they do not come back. The ocean keeps them. The creatures found in hadal trenches are collectively called hadal fauna. And the more scientists study them, the more they realize how unique these communities are. Each trench has its own mix of species. Each one has been isolated from the others by the ridges of the ocean floor for millions of years, allowing evolution to take different paths in different trenches. In the Mariana Trench, scientists have found species of bacteria that are not found anywhere else on Earth. It is single-celled organisms that have evolved in complete isolation for millions of years, in conditions no other bacteria on the planet have ever had to navigate. In a sense, the hadal trenches are islands. Not islands of land in the sea, but islands of extreme depth in the more moderate deep ocean. Just as islands of land can develop unique species over millions of years of isolation, think of the finches of the Galapagos or the lemurs of Madagascar. Islands of depth develop unique creatures shaped by isolation and extreme conditions. The Mariana Trench is an island at the bottom of the world, and like all islands, it holds wonders found nowhere else. One of the most fascinating things discovered in hadal research is the presence of diverse microbial communities living in the sediment. Not just on the surface of the sediment, but deep within it. Scientists have found living bacteria in sediment cores taken from tens of centimeters below the hadal floor. These organisms live in near total isolation, with almost no food, no light, no oxygen in many cases. They exist in a state of almost suspended life, metabolizing so slowly that their generation time, the time it takes for one organism to reproduce, might be thousands of years. Thousands of years. They are living in a different relationship with time than anything we usually think of as life. One division, one moment of reproduction, taking longer than all of recorded human history. I think about these slow, patient microbes sometimes when I feel rushed, when the world seems to be moving too fast and there is too much to do and not enough hours. Somewhere at the bottom of the Mariana Trench, something is alive and moving through time at a pace that makes a human lifetime look like a blink, a pace so slow it is almost indistinguishable from stillness. There are many speeds of being alive, many tempos of existence. The bacteria in the hadal sediment remind me that the slowest ones are not lesser. They are simply different, adapted to their particular corner of the universe, and maybe tonight, for you, being slow is exactly right. Slowing the breath, slowing the thoughts, moving towards sleep at a tempo that is closer to the hadal microbe than to the rushing surface world. Slow is not behind. Slow is exactly where you need to be. Chapter 14. Water itself. I want to take a moment to talk about water. Not the ocean as a place, not the creatures in it, just water itself, the molecule, the substance. The thing that makes this whole story possible. Water is, by almost any measure, one of the strangest substances in the universe. It should, by the rules that govern most molecules of its size and composition, be a gas at room temperature. Its two closest chemical relatives, hydrogen sulfide and hydrogen selenide, are both gases at room temperature. If water followed the same rules, it would be a gas too. The oceans would not exist. Life, as we know it, would not exist. But water does not follow those rules. It forms unusually strong bonds between its molecules, bonds strong enough to keep it liquid across a wide range of temperatures. This is why the oceans are oceans, and not vast clouds of water vapour. Water is also one of the only substances in the world that expands when it freezes. Most substances contract when they cool and freeze. Their molecules slow down and pack together more tightly. Water does the opposite. When it freezes, it forms a crystalline structure that is actually less dense than liquid water. This is why ice floats, and this, it turns out, is enormously important for life. If ice sank, lakes and oceans would freeze from the bottom up in winter. All the life at the bottom would be entombed. The deep water would freeze, the ice would sink, more water would freeze on top, more ice would sink, and eventually entire bodies of water could freeze solid, killing everything in them. Because ice floats, it insulates. It sits on top of the water, forming a layer that protects the liquid below from the cold air above. Life continues underneath. Fish and microbes and all the other inhabitants of cold water survive winter beneath their icy roof. At the bottom of the Mariana Trench, the water is liquid at temperatures close to freezing. The pressure is so high that it actually slightly lowers the freezing point of water, keeping it liquid at temperatures that might otherwise cause it to freeze. The water down there has a quality that scientists describe as almost gel-like under the extreme pressure. Not ice, not quite ordinary liquid water, but something in between. A state of water that does not exist anywhere else on Earth, except in those deep pressurized places. The trench has its own kind of water, water that the rest of the world has never experienced. There are around 18 known distinct phases of ice, different crystalline structures that water can form under different pressures and temperatures. Most of them only exist under conditions found deep in planets, not anywhere on the surface of the Earth. The deep ocean, in its own small way, creates conditions close to some of those exotic phases. Water, even familiar and ordinary water, still holds mysteries. The substance that covers most of our planet, that flows through our bodies, that falls from the sky and fills the rivers, we do not fully understand it yet. Scientists are still discovering new things about water's behaviour, its structure, its strange and rule-breaking properties. Maybe that's one of the quiet lessons of the Mariana Trench, that the most familiar things still hold depths. That even water, something you've known your entire life, is stranger and more wonderful than it appears. The world is deeper than its surface, and so, perhaps, are you. For a moment, just breathe. Feel the water in your own body, the blood moving slowly through your veins, warm and saline, not so different in its chemistry from the ancient ocean. We carry the sea inside us, in a sense. The salt concentration of our blood is an echo of the ancient ocean, from which all animal life emerged hundreds of millions of years ago. You're made in part of ocean, and the ocean in a way is made of time. Let that thought drift through you softly, like a current through deep water. Let's move gently onward to part 4, where we will go even deeper into reflection, and where the story will begin its slow, soft turn toward rest. But if sleep is already wrapping itself around you, welcome it. The trench will still be there when you wake. The pale snailfish will still be drifting in their dark and pressured world. The sediment will still be falling, layer by slow layer, building the library of the deep. And you will be rested, and the morning will come, and the world will be as it always is, quietly, steadily beautiful. Chapter 15. The Weight of Stillness. There's a particular kind of quiet that belongs only to very deep places. Not the quiet of an empty room, not the quiet of a library, where silence is maintained by agreement and effort. Not even the quiet of a field at night, where insects and wind and the distant sounds of the world still find their way to you. The quiet of the Mariana Trench is different from all of those. It is the quiet of distance, the quiet of separation, the quiet of a place so far removed from the surface world that even sound, which travels so well through water, arrives there changed, softened, slowed, like light passing through many layers of coloured glass, each one dimming it a little more, until what arrives is barely a suggestion of what it once was. At the bottom of Challenger Deep, the water barely moves. There are gentle currents, yes, even the deepest ocean has slow, cold flows of water driven by temperature and salinity differences. But they are gentle, unhurried, the kind of movement that takes decades to cover the distances that surface currents cross in days. Everything at the bottom moves slowly. The sediment falls slowly. The creatures move slowly. The currents flow slowly. The geology changes slowly. Even time, in some hard-to-define way, seems to move at a different pace down there. A pace measured not in seconds and minutes, but in layers of sediment and generations of creatures whose lives span hundreds of years. I want to sit with that slowness for a while tonight. Not as a curiosity, not as a scientific fact to be examined and filed away, but as a feeling, as something to inhabit. Because I think most of us, most of the time, live at the surface. We live in the sunlit zone where things move quickly, where light is abundant and change is constant, where the pressure of the day pushes in from all sides and we are always moving, always responding, always in the middle of something that seems urgent. And we forget that there is another way. We forget that somewhere below the surface of things, or below the noise and the urgency and the endless motion, there is stillness. Real stillness. Patient, ancient, unhurried stillness. The kind that has been there for millions of years and will be there for millions more. You do not need to go to the bottom of the ocean to find that stillness. It is available right now, in this moment, in this room, in this particular darkness where you are resting. It is available in the slow breath you're taking right now if you're breathing slowly. It is available in the weight of your body settling into the surface beneath you. It is available in the spaces between thoughts, the quiet intervals that exist between one idea and the next, if you let them be a little wider and a little longer tonight. The deep stillness is always there. We just have to remember to go down toward it instead of staying always at the surface. For a moment, just breathe. Let yourself go a little deeper. Chapter 16, Mountains in the Dark. Here is something that surprised me the first time I learned it. The Mariana Trench is not flat. The bottom of Challenger Deep is not a smooth, featureless plain of sediment stretching in all directions. When we think of the deepest place on Earth, we often imagine something like the floor of a very quiet room, even bare, still. But the actual topography of the hadal floor is complex and varied and, in its own dark way, dramatic. There are ridges and valleys within the trench itself. There are steep walls where the trench's sides plunge downward. Walls that, if you could see them, would be as dramatic as any mountain face on land. Yeah, there are mounds and depressions in the sediment floor. There are places where the rock of the trench wall has fractured and slumped, creating piles of debris that rest in the deep like fallen things. The walls of the Mariana Trench are among the steepest geological features on Earth. In some places, the trench wall rises at an angle of 45 degrees or more from the floor to the rim, a rise of nearly 11 kilometers in a horizontal distance of only a few kilometers. If you could stand at the bottom of the trench and look upward at the wall, you would be looking at something as tall as Everest and as steep as a ski slope. You would not be able to see it, of course. There is no light, but it would be there, enormous and dark, rising above you in the black water. Geological surveys using sound, sending pulses of acoustic energy down through the water and measuring the echoes that return, have revealed a detailed picture of the trench's topography. The floor of Challenger Deep is divided into 3 distinct basins, separated by small saddles or ridges. The western basin is the deepest, where the greatest depths have been recorded. The eastern and central basins are slightly shallower, but still among the deepest places on Earth. Each basin has its own character, its own sediment texture, its own population of organisms, its own subtle differences in temperature and water chemistry. Scientists who study the trench do not think of it as a single place, but as a collection of related but distinct environments, each one shaped by slightly different conditions. This is one of the things that makes the deep ocean so difficult to study and so endlessly interesting. Even within the deepest point on Earth, there is variety, there is complexity. There's not one answer to the question of what the Mariana Trench is like. There are many answers, each true for a different basin, a different wall, a different layer of sediment. The world is never as simple as our first picture of it. Every place, every person, every story has more depth than its surface suggests. The Mariana Trench taught us that the deepest place on Earth has mountains in it. Maybe that is a small and gentle metaphor worth keeping. That even in the deepest stillness there are peaks and valleys. That depth does not mean emptiness. That the bottom of things is not the end of complexity but the beginning of a different kind of it. Chapter 17. The oldest water. I want to tell you about the water at the bottom of the Mariana Trench, not its pressure or its temperature, which we have already talked about, but its age. The water in the deep ocean is old, very old, not in the way that rocks are old. The water molecules themselves cycle through the Earth's systems over long periods of time and are not fixed in one place forever. But the water currently sitting at the bottom of the Mariana Trench has been on its journey for a very long time. Ocean circulation is driven by differences in temperature and salinity. Cold, salty water is denser than warm, fresh water, so it sinks. In certain places in the world, primarily in the North Atlantic near Greenland and in parts of the Antarctic, cold, dense water sinks from the surface and begins a slow journey along the bottom of the ocean. This sinking cold water drives a global circulation pattern that scientists call the thermohaline circulation. Sometimes it is called the ocean conveyor belt. It is the slowest conveyor belt imaginable. Water that sinks in the North Atlantic takes roughly 500 to 2,000 years to complete one full cycle of the ocean. It moves along the deep ocean floor slowly in the cold dark, travelling from the Atlantic through the Indian Ocean and into the Pacific, gradually warming and mixing, eventually rising back to the surface somewhere on the other side of the world and beginning its journey again. The deep water of the Pacific Ocean, the water sitting in and around the Mariana Trench, is among the oldest ocean water on Earth. And some of it has been in the deep for over 1,000 years. It sank from the surface more than a millennium ago, perhaps in a world where there were no printing presses, no gunpowder in Europe, no Americas known to the Old World. That water has been sitting in the dark ever since. It carries, dissolved within it, gases and nutrients and chemical signatures from the surface world of 1,000 years ago. Scientists can read these signatures using chemistry to understand something about the surface conditions of a world long gone. The deep ocean is, among its many identities, a time capsule, a message in a bottle sent from 1,000 years in the past, still floating, still unread, still travelling slowly toward an uncertain future. There is something extraordinarily beautiful about that. Right now, as you lie in the dark and let your thoughts grow quiet, that ancient water is sitting in its trench, patient, cold, full of dissolved memories of a surface world that no longer exists. We are connected to the past in so many ways we do not see. The air we breathe contains molecules that have passed through the lungs of creatures long extinct. The water in our bodies has cycled through oceans and clouds and rivers and rain for billions of years. We are made of old things. We are made of time. And tonight, resting, we are part of that long continuity. One quiet moment in a story that started long before us and will continue long after. That is not a lonely thought. It is a connecting one. For a moment, just breathe. Feel the ancientness of the air entering your lungs. Feel the weight of everything that has come before. Resting lightly on this present moment, you are here. That is enough. Chapter 18. What lives in the walls. We have talked about the floor of the Mariana Trench, the pale sediment, the drifting amphipods, the ghostly snailfish. But the trench has walls too, and the walls have their own community of life. The walls of the trench are made of rock, basalt mostly, the dark volcanic rock that makes up most of the ocean crust. In places the rock is bare and steep, worn smooth by slow geological processes. In other places it is fractured and rough, creating surfaces where organisms can attach and find shelter. On these rock walls scientists have found foraminifera, the same tiny shelled organisms whose remains make up much of the trench sediment, living attached to rock surfaces, feeding on the organic particles that drift down from above. They live in the walls of the world's deepest canyon, clinging to rock faces in the dark, going about their small and ancient lives. There are also xenophyophores. These are single-celled organisms, but they are among the largest single cells in the world. Some species of xenophyophore grow to be more than 20 centimeters across. A single cell, large enough to hold in your hand. They build themselves elaborate structures of sediment and minerals, creating what look like tiny, intricate towers or fans on the trench floor and walls. Under a light, they would look almost like small works of art. Natural sculptures built by a single cell in the dark. No human eye has seen most of them. They have built their structures in complete darkness, in a place no light has ever reached, in conditions no human body could survive, and they are exquisite. This seems important to me in a quiet way. Beauty does not require an audience. The xenophyophores do not build their structures for anyone to see. They build them because it is what they do, what millions of years of evolution has shaped them to do, what the chemistry of their cells compels them to do. And the result is beautiful, even if the only witnesses are the cold, dark water and the occasional research lander. Things can be beautiful without being seen. Lives can be meaningful without being documented. The work of being alive, the simple, persistent work of finding food and growing and continuing, has its own dignity, regardless of whether anyone is watching. Maybe that is something to carry into sleep tonight. The thought that your life, even on its quietest days, even in its most private moments, even in the unwitnessed hours of rest and sleep and the slow turning of the night, your life has the dignity of being alive, of being here, of continuing, like the xenophyophore in the dark, like the ancient water in the trench, like everything that persists quietly in the deep places of the world. Chapter 19. Returning to the surface. Every person who has ever descended into the deep ocean has had to come back. The Trieste, the deep-sea Challenger, every unmanned lander ever lowered on a long rope, every ROV piloted from a ship above. All of them eventually have had to leave the deep and return to the surface. There is something about that return that I find worth thinking about. Jacques Piccard and Don Walsh. Ascending from the bottom of Challenger Deep in January 1960 must have experienced something strange and profound in those 3 hours of rising. They had been somewhere no human had ever been. They had touched the bottom of the world, and now they were leaving it behind, rising back through the darkness, through the cold and the pressure, through the twilight zone and back toward the light. What do you bring back from a place like that? Picard later wrote and spoke about his deep dive with a kind of quiet reverence. He had seen the fish at the bottom. He had confirmed that life existed even there. He had been to the deepest, most remote, most inhospitable place on the planet and found it inhabited, found it alive. He brought that knowledge back to the surface, that life is more persistent than we think, that the universe is more hospitable than we imagine, that wherever there is water and chemistry and even the smallest amount of energy, something will find a way to live. James Cameron, surfacing from his solo dive in 2012, spoke about the strange psychological effect of returning. He'd been alone in that small vessel for hours, in a place completely disconnected from the rest of humanity. And when he broke the surface and opened the hatch and felt the Pacific air on his face and saw the blue sky above him, he felt, he said, a profound sense of both relief and loss. Relief to be back in the familiar world, loss for the extraordinary, silent, otherworldly place he'd just left behind. There is something true in that feeling. The deep places of the world, the remote places, the quiet places, the places far from noise and speed and complexity, they change something in us when we visit them, even in imagination, even in a story listened to late at night, in the dark, when the world outside is still. Something in us recognizes the value of stillness, the importance of depth, the necessity of sometimes going down instead of up, inward instead of outward, slow instead of fast. And then, like Picard and Walsh and Cameron, we return. We come back to the surface. We open our eyes and the morning is there, ordinary and warm and full of the particular busyness of a life being lived. But we carry something back with us, a memory of stillness, a sense that the world is deeper than its surface, a quiet certainty that life persists in extraordinary places, and that the universe is far stranger and more generous than we usually remember. Those things are worth carrying. For a moment, just breathe. Let the image of rising slowly through dark water fill your mind. Not frightening, not cold, just the gentle, weightless feeling of moving upward through stillness. The darkness gradually warming toward blue, the blue gradually brightening toward light. You do not need to rush toward morning. Morning will come on its own. Let yourself float in this particular darkness for a while longer. The world turns slowly, and so do we. Chapter 20. The Trench and the Self. We're getting close now to the quietest part of our story, the part where the information becomes less dense, and the reflection becomes softer, and the words begin to space themselves out like islands in a wide, still sea. But before we fully arrive there, I want to sit with one more idea. The Mariana Trench is the deepest place on Earth, and in exploring it, in sending our instruments and our imagination, and occasionally brave human beings down into it, we have learned not just about the ocean. We have learned something about ourselves. We have learned that our planet is stranger and more complex than we imagined, that life is more persistent, that the rules we thought were universal are, in fact, local, that conditions we consider impossible are simply unfamiliar. That extremity does not mean emptiness. We have learned that even the most isolated, most remote, most forbidding places on Earth are not empty. They are full of creatures and chemistry and history and time, full of sounds and sediment and slow, patient lives being lived in the dark. And I wonder sometimes if that is also true for us, for the deep places inside us, the parts of ourselves we rarely visit, the parts that are quiet and slow and a little unfamiliar, the inner places that seem, from the surface, to be remote and difficult and perhaps not worth the journey. Maybe those places are not empty either. Maybe they are full of strange and extraordinary things, old memories settling like sediment, feelings moving slowly like deep currents, something patient and persistent and alive, doing its quiet work in the dark, waiting for the light of attention to occasionally find it. We do not need to explore those places tonight. Tonight is for rest. Tonight is for the surface to grow still and the depth to be simply acknowledged, not examined. But perhaps tomorrow, or some quiet afternoon, or some other night when sleep is slow in coming, perhaps then a little gentle self-exploration might be worthwhile. A little willingness to go down instead of staying always at the surface. A little patience with the slowness of deep things. The Mariana Trench has been patient for 180 million years. Your own depths have been patient too. They will wait for you. For a moment, just breathe. Let your thoughts grow slower. Let the spaces between them widen. You are drifting now, drifting toward the quietest part of the story, toward the soft place where sleep lives, gentle and warm and waiting. Let's drift there together, slowly, in the last part of our story. Chapter 21, The Last Descent. We are near the end now, not the end of the ocean, not the end of the trench. Those will continue long after this story's finished, long after you and I are both gone, long after the last word of this narration has dissolved into the quiet air of your room. But we are near the end of our time together tonight, and I want to spend this last part gently, softly, with no new urgency, no new complexity, nothing that asks too much of you. Just the slow, warm closing of a story, like the last few miles of a long journey home, when you already know where you're going and the road is familiar and the destination is close, and you can let your shoulders drop and your grip loosen and simply be carried the rest of the way. So let me tell you, very gently, a few last things about the Mariana Trench, and then let me just sit with you for a while in the quiet. The trench is still being explored, slowly, carefully, with better tools every year. Scientists are developing new generations of hadal landers, unmanned vehicles that can stay at the bottom longer, sample more carefully, move more precisely. New acoustic mapping systems are creating the most detailed pictures ever made of the trench floor. New sequencing technology allows scientists to identify organisms from trace amounts of DNA collected in water samples without ever needing to see the organism directly. We are learning more every year, slowly, patiently, the way the trench itself does everything. In recent years, full ocean depth submersibles have become more available for scientific research. A new generation of deep-sea vehicles can now carry human passengers to the bottom of the Mariana Trench, not just once or twice in historical moments, but repeatedly. As part of ongoing scientific programs, more human eyes are seeing Challenger deep than ever before, and every time someone goes down and comes back, they bring new pieces of the puzzle, a new species identified, a new measurement taken, a new understanding of how water moves at those depths, or how the sediment is layered, or how the creatures of the hadal zone interact with each other. The puzzle is enormous. The pieces accumulated so far are few, but they are growing in number, and each one is beautiful. Chapter 22. What the ocean asks. The ocean asks nothing of us. It does not need our attention or our admiration. It does not wait for us to discover it or understand it or protect it. It has been here for billions of years, and it will continue in one form or another long after us. And yet somehow, there is something in us is drawn to it. Even people who have never seen the ocean in person carry something of it inside them. A pull toward the vast and the deep. A fascination with the unknown. A feeling, when they look at photographs of the dark sea or read about the creatures of the hadal zone, that this place is part of them somehow, that the connection between human beings and the ocean is not just ecological or biological, but something older and less rational than that. Maybe it is because we came from the ocean, not as individuals, not in our lifetimes, but as a species, as life. The first living things on Earth emerged in the ocean billions of years ago. Every creature that has ever walked on land or flown through the air carried the ocean inside it, in the salt chemistry of its cells, in the ancient blueprint of its biology. We are, all of us, children of the sea in the deepest and most literal sense. And perhaps that is why the ocean feels like home to something inside us, even when we stand on dry land 1,000 miles from any coast. Even when we lie in a bed in a city, far from any water, listening to a story about the deepest place on Earth, something recognizes it, something knows. The Mariana Trench, in a way, is the most ancient home we have, the deepest, oldest, most unchanged corner of the world from which all life on Earth descended. Its cold, dark water has been there since before animals existed. Its slow currents have been moving since before the first fish developed eyes or fins or the instinct to swim toward light. It is the oldest room in the oldest house, and tonight, in some small way, we have visited it. Chapter 23, Soft Things in Dark Places. I want to leave you with some images, not ideas, not facts, just images, soft and slow to carry into sleep. Imagine the sediment floor of Challenger Deep, pale and still, a fine, soft layer of diatomaceous ooze, smooth as flour covering the deepest surface of the Earth. Nothing disturbing it right now, no lander, no camera, no human instrument, just the sediment lying in the dark, the way it has lain for millions of years, patient and undisturbed. A sea cucumber drifts very slowly just above the floor. Its body is pale, almost translucent, rippling gently as it moves. It is going nowhere in particular. It is simply moving, the way living things move, because movement is what life does. Its pace is so slow that it seems barely distinguishable from stillness. But it is alive. It is here, and in its own quiet way it is going about the work of being. Somewhere nearby, in the beam of an imaginary light, a snailfish drifts. Its body is soft and ghostly. Its fins move in slow, delicate arcs, barely disturbing the water. It is searching for food, or perhaps it is simply being, the way creatures sometimes simply are, without urgency, without plan, just present in the moment of their existence. Above it, thousands of meters above, the water column rises in darkness. Nothing visible, nothing but cold, dark, still water, slowly, slowly moving. Somewhere in the middle depths, a sperm whale passes, moving steadily through the black. Its sonar clicks echo off into the distance, searching for food or perhaps simply mapping the world, the way we map things, because knowing where we are is a kind of comfort. Higher still, the sunlight begins, faintly at first, a distant cold suggestion of blue, then warmer, then brighter, then the full, warm, gold and green of the surface zone, where everything moves quickly and light is abundant and life is loud and various and busy, and above the ocean, the sky, blue and wide and full of clouds moving slowly in the wind, and somewhere under that sky, in some particular place on this particular planet, you're lying in a room in the dark, with your eyes closed or nearly closed, with your breathing slow and your body heavy, and your thoughts growing soft and formless at the edges. You're at the surface of things, at the bright, warm, breathing surface of a world that goes down and down and down beneath you, through rock and water and pressure and time, all the way to the deepest place that exists. And all of it. Every layer, every zone, every creature, every current, every ancient molecule of water, all of it is part of the same extraordinary thing, this planet, this living, turning, patient, astonishing world, and you are part of it too. Chapter 24. Going gently. The ocean does not rush. It never has. Not in 4 billion years. It has moved according to its own rhythms, the slow pull of the moon creating tides, the long cycles of climate creating currents, the even longer cycles of geology creating trenches and closing them again. It has moved to the rhythm of deep time, not human time, and deep time is gentle. It is not in a hurry. It has all the time there is. Tonight, you're invited to borrow a little of that rhythm, to set down just for these remaining hours of darkness. The pace that the surface world asks of you, the quick pace, the responsive pace, the pace of screens and messages and plans and the next thing always waiting after this thing. Set it down. You can pick it up again in the morning. It will be there. For now, just the slow rhythm, just the breath moving in and out, the way currents move through the deep ocean, just the body resting, the way sediment rests on the floor of the Mariana Trench, just the mind growing still, the way water grows still at great depth, where the surface turbulence cannot reach. If thoughts come, let them come. Do not chase them. Do not resist them. Just notice them the way you might notice a deep-sea creature caught briefly in a beam of light, there for a moment, then drifting away into the dark. You're not required to solve anything tonight. You're not required to understand anything tonight. You're not required to be anything other than what you are. A warm, breathing, resting person, in a bed, in a room, in a world that is larger and stranger and more beautiful than any story can fully contain. For a moment, just breathe. Notice how quiet it is. Notice how still. Chapter 25. The language of deep water. Water has its own language, not words, not sentences, but a language of pressure and temperature and chemistry that moves through the ocean like whispers moving through a long dark hallway. A language that has been spoken since the first raindrop fell on the young cooling surface of the earth and the first ocean began to gather in the low places of the ancient rock. We do not speak this language, we have never spoken it, but we can learn, slowly and quietly to hear some of it. We hear it when we stand at the edge of the sea and feel the pull of the surf around our ankles, that gentle, insistent tug that seems to say, come further, come deeper, come in. That is the language of water speaking to the ocean memory in our cells. We hear it when rain falls on still water and the surface erupts in 1,000 tiny circles, each one spreading outward and overlapping with the others, creating a pattern that is perfectly mathematical and perfectly beautiful and perfectly natural all at once. That is the language of water writing itself on its own surface. We hear it in the sound of a river moving over stones, in the drip of water in a quiet room, in the particular sound of the ocean at night when the waves come in long and slow and the foam hisses softly as it spreads across the sand and then pulls back, always pulling back. The Mariana Trench speaks this language too, but its dialect is the deepest and the slowest of all. Down there, the language of water is spoken in movements of millimeters per day, and temperature changes of fractions of a degree over centuries. It is a language of almost infinite patience and almost infinite subtlety. Scientists who dedicate their lives to the deep ocean sometimes speak about it with a kind of reverence that goes beyond the scientific. They have given their careers to a place they can barely visit, studying a world they can barely see, trying to learn a language they can barely hear, and still they go back, Still, they design new tools and write new grant proposals and spend months at sea in support ships waiting for their landers to come back from the bottom. Because there is something down there worth knowing, something that changes you, even from a distance, even through the lens of science and data and careful measurement. The deep ocean reminds you that the world is incomprehensibly large and incomprehensibly old and incomprehensibly full of things you did not expect. And that reminder is one of the most valuable things available to a human being. Because when you feel the weight of the world pressing down on you, the ordinary human surface world weight of worry and responsibility, and the endless small demands of a life being lived, it helps to remember that just below that weight, below all of it, there is an ocean. And below the ocean there is a trench, and at the bottom of the trench there is a world of extraordinary stillness and patience and life persisting in impossible conditions, and that world does not know about your worries. It does not know about deadlines or disappointments or the things you said that you wish you had not said, or the things you should have done that you did not do. It simply continues, slow and dark and full of pale, drifting things going about their quiet business. It continues, and somehow, knowing that it continues, knowing that somewhere on this earth there is a place of such complete and ancient stillness, makes the weight a little lighter. For a moment, just breathe. Let the language of deep water move through you, slow and soft and without words, just the feeling of depth, of patience, of something enormous and quiet, holding you gently from below. Chapter 26. What remains? Every explorer who has ever gone to the Mariana Trench has left something behind, not deliberately, not carelessly, but inevitably, because visiting a place means leaving a trace of yourself in it. The Trieste's landing left 2 small impressions in the sediment of Challenger Deep, the marks of its footpad settling into the ooze in January of 1960. Those impressions are almost certainly still there, covered perhaps by decades of slowly settling sediment, but there, somewhere, in the deepest quiet. James Cameron's deep-sea Challenger left its own traces. The disturbance of its thrusters in the water, the small cloud of sediment stirred by its landing, the chemical signatures of its systems, all left behind in the deep. Even the unmanned landers the robotic vehicles sent down on long ropes leave traces, footprints in the ooze, disturbed sediment, small amounts of material carried down from the surface world and left behind in the deep. We leave traces everywhere we go. This is not a sad thing. It is simply the nature of being physical, of existing in a material world where everything touches everything else, and nothing passes through without leaving some small sign of its passage. You leave traces too, in every place you have ever been, in every person you have ever known, in every conversation and every quiet moment and every small act of kindness or care or attention. You have left traces, small impressions in the sediment of the world, not always visible, not always acknowledged, but there. The world is different because you have been in it. Not in enormous dramatic ways perhaps, but in the real quiet accumulating way that sediment accumulates on the floor of the Mariana Trench, layer by layer, year by year, slowly building something that, seen from far enough away and with patient enough eyes, is substantial and real and worth something. You are worth something. Your presence in the world has left its mark on the world, the way every presence does, and the mark is real even when you cannot see it, even on the days when you feel invisible or insufficient or like nothing you do quite reaches the surface of being noticed. The Xenophyrophore builds its intricate structure in the dark. No one sees it, and yet it is there, real and beautiful and part of the world. So are you. Chapter 27. The Trench at Rest. Right now, as you listen to these last words, The Mariana Trench is exactly as it has always been. Cold, dark, still. The sediment is settling, one layer upon another, as it has settled every day for millions of years. The xenophoras are in their small, intricate structures, going about whatever slow process constitutes their living. The amphipods are drifting, or resting, or gathering around some distant foodfall, doing what they do without awareness of being watched or studied or wondered about. The ancient water is moving in its slow current, carrying its dissolved chemistry from a surface world that existed 1,000 years ago, bound for somewhere it has been slowly heading all this time. The walls of the trench rise in the dark, enormous and silent, coated in rock and sediment and the slow, patient work of millions of organisms over millions of years. The Pacific plate is moving, a few centimetres this year, a few more next year, slow beyond all human sense of slow, but moving steadily in the direction it has always moved, deepening the trench by another fraction, adding to the story by another line, and high above all of it, at the surface of the Pacific Ocean, the water is moving. It is night there too, in that part of the world. The stars are reflected in the dark water, trembling slightly with each small wave, the ocean breathing. Below that, the long, dark, patient descent, through the sunlit zone gone dark for the night, through the twilight zone where bioluminescent creatures make their own small stars, through the midnight zone where the darkness is so complete it has weight, through the abyssal zone where life is sparse and slow and extraordinary, and then, just past the edge, past the rim of the trench, down the steep walls, past the ancient sediment, past the drifting creatures, down to the floor of Challenger Deep, where everything is still, where the pressure is enormous and the temperature is just above freezing, and the darkness is absolute, and the quiet is the deepest quiet on Earth, where the world began, in a sense, where life persists against all expectation, where the planet keeps its oldest secrets, where the sediment settles and the water moves and the creatures go about their quiet lives, completely indifferent to whether anyone knows they are there. They are there. They have always been there. Chapter 28. The Gift of Rest. Sleep is one of the most ancient things a living creature can do. Long before humans existed, animals slept. Long before animals, the earliest complex organisms had cycles of activity and rest built into their biology. Even some single-celled organisms show rhythmic patterns that scientists believe are the deep evolutionary ancestors of sleep. Rest is not a luxury, it is not laziness, it is not wasted time. Rest is as fundamental to life as a movement, as necessary as food, as ancient as the ocean itself. When you sleep tonight, you are participating in something that life on Earth has been doing for hundreds of millions of years. You're joining a rhythm as old as biology. Your body knows this rhythm. It was built for it, shaped by it, sustained by it. Every cell in your body knows how to rest. Every system in your body knows how to slow down, repair, restore, renew. You do not need to do anything to make this happen. You do not need to try. You just need to stop not sleeping. Stop holding yourself at the surface. Stop keeping yourself in the sunlit zone when the deep restorative dark is right there, available, waiting. Let yourself go down, not into the cold dark of the Mariana Trench, into the warm, soft dark of sleep, into the place where the body heals itself quietly, where the mind processes the day's experiences and files them softly away, where dreams sometimes offer strange and generous gifts, and where, more than anything else, you are allowed to simply be unconscious for a while, to not be in charge, to not be responsible, to not be aware. That is the gift of sleep. Tonight, that gift is yours. You have earned it. the way every living thing earns rest by spending itself in the work of being alive. Let yourself receive it. A closing word. Thank you for travelling with me tonight. We went somewhere extraordinary together, down through the sunlit waters and into the dark, past the twilight and through the midnight and into the deep abyssal, all the way to the bottom of the world, to the floor of the Mariana Trench, to the place where human beings have only rarely gone, and where most of the universe of life has never been seen by any human eye. We talked about pressure and about creatures, about sound and about sediment, about the age of water and the patience of time, about what it means to be small and temporary in a world that is ancient and vast, about the beauty of things that no one sees, about the dignity of lives lived quietly in the dark, about what remains when we are gone, about the gift of going slowly in a world that always wants to go fast. I hope some of it was interesting. I hope some of it was calming. I hope that the image of the deep ocean floor, pale and still and full of slow, extraordinary life, can be a gentle place. Your mind visits sometimes when the surface world feels too loud and too fast and too demanding. The deep is always there. The stillness is always available. You do not have to go anywhere to find it. It is right here, in the quiet between one breath and the next, in the weight of your body resting, in the particular darkness of a room where someone is letting themselves finally, gently, completely rest. You are safe. You are warm. The world outside is doing what it always does, turning slowly, quietly in the dark. The Pacific Ocean is breathing its long, slow breaths. The Mariana Trench is sitting in its ancient stillness. The pale snailfish is drifting in the dark water miles below the surface, unhurried and unbothered, going about the quiet miracle of being alive, and you can let all of it continue without your help tonight. You have done enough today. You have been enough today. Whatever was left unfinished, whatever was imperfect, whatever still waits for your attention, it will all be there in the morning, and you will meet it rested, and that will make all the difference. For now, just this, just the breath, just the warmth, just the quiet, just the soft darkness of a room where someone is falling asleep. Let your thoughts drift like sediment drifting slowly downward in still water, softly, without direction, without urgency, simply settling. Let the images grow softer, the snailfish fading into pale, the sediment dissolving into white, the dark water becoming simply dark, the dark becoming simply warmth, the warmth becoming simply rest. Let the story end the way the ocean ends at its deepest point, not with drama, not with a sharp conclusion, but with stillness, with a slow, soft settling into the deepest quiet. The world turns slowly, and so do we. Good night, sleep well, the deep is patient, and so is morning.